Let's now see how we can use our database as a queue to enqueue our notification events and process them in a stateful manner. When a customer makes an order, we know that an order will be added to our orders table in the database. Now we want to take a step further and enqueue a notification event for each order that is created. Each notification event is going to be associated with an order, and it will have information like you see in this green and a blue box. The green box represents the status of the order, while the blue box represents the state of this notification event. And please keep in mind that when we say stateful, we are referring to the state of whether the notification email was successfully sent or not. So the notification state, which is the blue box, is what is important here and what makes this database queue stateful, and the green box has nothing to do with the statefulness of the database queue. So when an order is first created, the status of the order will be in a pending state, and we're going to have an endpoint for admins to update the status of the order. When the admin ships the order, for example, the admin is going to update the status of the order, and another notification will be enqueued into the database queue. You can think of each notification event as each email notification. And because we want to send an email notification when an order is pending, and again when the order is shipped, and also when it is delivered, we will enqueue an event for every update on the order status. The notification state of each event will be stored in a separate notification states database table. Please keep in mind that this is just a database table and not a queue. So when the notification event is successfully sent or it fails after a few attempts, the state of each notification event will be stored in a database while the events would have been dequeued and processed from the queue by then. This separate notification states table will allow us to maintain a record of exactly what notification failed for which status of which order. Now that we learned a little about how we maintain the state of the notification events, let's have an overview of how our orders are processed. Imagine we have two customers where one customer makes order 1 and the other makes order 2. And let's add another event as well. For example, an order 1 was shipped in the meantime as well. Because we have a queue, the events will be processed first in, first out. We'll later have an ecom notification microservice that will list these events based on the timestamp of when the event was created. And then it is going to send the notification email for each of the notification event concurrently in Go routines. The attempt to send an email might succeed or fail. Upon failure, it splits up into two possible scenarios. Each event keeps track of how many attempts have already been made to send an email for this notification event. And if we set an arbitrary maximum number of attempts as 3, we can have a scenario where the attempt count is less than 3 and we can retry, or another scenario where we exceed the number of attempts. So if we were to have a closer look at each of these scenarios, in a successful case, we'll delete or dequeue the event from the notification queue and update the corresponding record in the notification states table to a sent state. If the attempt fails and the attempt count is less than 3, we'll increment the attempt count by 1 and update the database table. If the attempt count of the notification event has exceeded the maximum number of attempts allowed, we will delete or dequeue this event from the notification events queue table and update the record in the notification states table to failed. The admin will then be able to maintain records of the state of these notification events and decide what to do with them. In this episode, we're going to add the endpoint as well as the corresponding store, RPC, and the handler methods to update the status of the orders. We'll also add the store method to enqueue the notification events into a database queue, as well as the store and the RPCs to list and update the notification events that will be used by our ecom notification microservice. And we'll add this microservice in our next episode, where we're going to spin up Go routines to send email notifications every 10 seconds and also restrict concurrency using semaphores. And our microservice is going to update the notification events accordingly based on whether it succeeds or fails to send the notification email. So we're first going to add the endpoint to update the status of the orders. I'll open my terminal and run this command to add the migration file. In case you haven't watched the previous episodes, we're using this migrate image to create a migration file called add_order_status. And our migration files will be added inside our db/migration directory, which is here. So we'll see that we have an up file as well as a down file. And inside this migration up file, I'm going to add this query to alter the orders table to add the status column of enum type, and I'll give this a default value of pending. And inside our migration down file, I'm going to add this query to drop the status column. I'll save and close these files, and I'm going to start from creating the store method to update the status of the order. Before we add any store method though, let's come to our store types.go and add our enum type to our order struct. So I'm going to create a new type called order status of type string, And I'll create 3 different consts of this order status type. Then inside the order struct, I should be able to add this status field of order status type with this db tag. Now that we have added our status field to our order struct, I'm going to come back to my store MySQL file, and right under this getOrderStore method, I'm going to add this method to get the order status by ID. So if you remember, our getOrder method gets the order based on the ID of the user, whereas our getOrderStatus by ID gets the ID, user ID, status from the orders table based on the ID of the order. We could somehow combine these 2 methods into one, but I'm not going to get to that part in this video. Then I'm going to scroll down a little bit, and below this list orders store method, I'm going to add this method to update the status of the order. So given the ID of the order, we're going to update the status as well as the updated at field of this order. And that's all we need here for now. I'm going to close these files and come to our ecom grpc api.proto file. And just like what we did for the store types, I'm going to add an enum for the order status. So right below this order item definition, I'm going to add this order status enum and add 2 more fields to the order request definition. I'm going to add the user email as well as this order status. And same for the order response definition, I'm going to add this status field of order status enum type. And lastly, in our RPC definitions, right below our list orders RPC, I'm going to add this RPC to update the order status that takes in the order request and returns an order response. And then I'm going to open my terminal to run protoc command to compile these new proto definitions. If you've watched the previous episode, you should know how this is done. First, you have to make sure that the path to your go/bin directory is added to the path. And you can simply run this protoc command with all these flags as well as our api.proto file. This will add new changes to our api.pb.go and the api grpc.pb.go. As you can see inside the ecom client interface, the update order status has been added, and same inside our ecom server interface. Now I'm going to open my grpc server.go file. Right below the list orders method, I'm going to add this method to update the order status. This will take in a context as well as our pb.orderRequest struct and return pb.orderResponse as well as an error. And before we call our store method to update the status of the order, we first want to validate this order request. That's why we added the store method to get order status by ID. We're going to pass in the context as well as the order ID from the order request. And if there is an error, we're just going to return nil and an error. And I first want to validate the user ID of this order request. I'm going to make sure this is the same as the user ID in our database. And if they're not the same, I'm going to return an error saying order does not belong to user. I'm going to pass in the order ID as well as the ID of the user. I'll save this real quick. And I also want to validate the status of this order. So we want to make sure that the status of this new order request does not already exist in the database. So if the status of the order request is equal to the status of the order in the database, we want to return an error that looks something like order status is already the status of the order. But you'll notice that we have an error here saying that the status of this order request doesn't match the type of our order.status. So what we can do is to convert the status of our order request. So right up here, we can call .string method on this getStatus method, but this string is going to be in uppercase, for example, pending. So we first want to change them into lowercase by calling strings.toLower and then convert them into the order status type like this, and I'm going to store that in a new variable called sorderStatus. And I'm going to copy this and paste this here instead. And now we will be able to compare the status of the order request to the status of the order in the database. So if we pass this validation, we would be able to assign this new order status into the status of our order. And we should also remember to update the updated add field of our order. And because our updated add is of pointer type of time, we're going to call this helper method to time pointer and pass the current time. I'll save that, and once we've done that, we can call store.updateOrderStatus pass in the context and our order, and this will return our order response and an error if there is. And if there's an error, we're going to return nil and an error. And before we return our order response, this is where we would want to enqueue our notification event once we have that store method. And at the end here, I'm going to be able to return the order response. I notice I have a typo here, so I'm going to change this real quick and save this file. But before we move on to the next part, we have to modify our toPBOrderResponse method a little bit. We want to make sure that the status of our order is included in the order response. However, I wouldn't be able to pass the order status into the pb.orderResponse because the types don't match. So I'm going to add another helper method up here to convert the store.orderStatus into pb.orderStatus. Now I can pass this order status into this helper method, and that should be all we need to do here. I'm going to close these files and move up to our handler file. And again, before we add our handler method, I'm going to add this new status field to our order request type. So inside our order request struct, I'm just going to add this new field status of string type and a JSON tag. And same for the order response struct, I'm going to add the status field of string type with the JSON tag. And then I'm going to move into the mapping.go file inside the handler package. And inside our toOrderResponse method, I'm going to add this status field. And just like what we did earlier, I'm going to call getStatus.string and pass this into strings.toLower. And right above this method, I'm going to add another helper method to convert the order status string into pb.orderStatus. I also added this order status type as well as these three constants of each order status. Please keep in mind that this method has the same name as the helper method inside our server mapping.go, as you see here, but they're different because this helper method converts the order status string into pb.orderStatus, whereas the other mapping we have here converts the store.orderStatus into pb.orderStatus. I'm going to close that file to avoid confusion and save this file. And now that we have added our helper methods and changed our structs, we can define our handler method to update the order status. So right below our list orders method, I'm going to paste this handler method that I prepared in advance. And there's actually a small error here because our order request doesn't have the ID field. So I'm going to remember to do that as well. Inside our types.go file, I'm going to add this new field ID of type integer64. Save that, and I'm going to come back here, and now the error should have disappeared. And I'm pasting this method here because it's very similar to what we've been doing so far. All we're doing here is reading the user claims from the context that's passed down from middleware, and we're also reading the request body into our order request struct. Then we're calling this toPBOrderStatus method that we just created in our mapping.go file to convert our order status into the pb.orderStatus. Now we can pass this status into our pb.orderRequest struct along with the ID of the user from the claims, the email from the claims as well, and lastly the ID from the order request. This ID can come from the request body or from the URL parameter if you would like. It shouldn't really matter. And at the end of the method here, I'm returning status no content, but I think it makes more sense to return a response. So I'm going to get rid of this and paste this to set the header and return this as a JSON response. And one last thing we want to do here is, of course, to add this updateOrderStatus endpoint. So inside this list orders endpoint here, I'm going to add this route with the admin middleware, pass in the token maker, and this endpoint is going to accept a patch request on the status endpoint. Then I can pass my updateOrderStatus handler method. So we're now done with the first part here to update the status of the order. Now let's see how we can add notification events queue and the notification states table and add the corresponding methods to enqueue, list, and update those notification events. I'm going to start by adding the migration files for the notification events queue table and the notification states table. I'm going to open my terminal and run this command to add new migration files and close these files and open the new migration file that has been created. Inside the up file, I'm going to paste these queries to add the notification states and the notification events queue tables, where the notification events queue table is going to have the user email, the status of the order ID with the foreign key constraint, as well as the state ID, number of attempts for each of the events, as well as the created and the updated add timestamps. The notification states table has the order ID with the foreign key constraint and the state of enum type with the not sent, sent, and the failed state. And we also have a message field mostly to show why the event failed to send. I'll save this file, and inside our down migration file, I'll paste these queries to drop the foreign keys as well as the tables. I'll save this file and close them. I'm going to start from the ecom grpc store types.go file, and at the bottom here I'm going to paste these new constants that will represent the 3 different types of states that we have. And then we also have the notification response type that will be used to tell us if the email was successfully sent or not. Then we also need structs for the notification state and the notification event, and each of the structs are going to have fields that correspond to the fields in the database. And once we have these structs defined, I'm going to move into my store mysql.go file, scroll to the bottom, and add my store method to enqueue my notification event. This will take in a context and a notification event and return a pointer to the notification event as well as an error. And inside our enqueue notification event method, we're simply going to insert a notification state and a notification event in the queue in a database transaction. We already have a helper method to run these in a database transaction. So I'm going to call ms.exectx. Then I'm going to need separate methods to insert into the notification states table and into the notification events queue table. I already have those methods prepared, so I'm going to paste those methods up here. So with the insert notification state method, we are adding the order ID, state, and the message into the notification states table using the notification states struct we have. And with the insert notification event method, we are inserting the user email, order status, order ID, state ID, and the attempt into the notification events queue with the notification event struct that we pass down as an argument. Now back inside our enqueue notification event method, I can now call insert notification state, pass in the context, our transaction, and the notification states struct. The order ID is going to come from the notification event struct there, and the state will be of not sent, and we'll have an empty message in the beginning. This will give us a notification state struct as well as an error if there is. And if there is an error, we're going to return an error saying error inserting notification state. And then we can assign the state ID from the notification state into the notification event struct before we call insert notification and pass the notification event as an argument. This will give us the notification event as well as an error. So if there's an error, again, we can say error inserting notification event. And I'm just going to get rid of these comments here, return nil, and also get rid of this here and here. And then outside of this database transaction, if there is an error, we can return an error saying error enqueuing notification event, and then return this notification event and nil for the error. And we're actually not returning the notification event that we inserted into the database. So I'm going to define a new variable and call it EV of type notification event. And I'm going to store the result of the insert notification event into this EV variable and return this EV as the response. So now that we have the enqueue notification event method, we can call this from our CreateOrder and the updateOrderStatus methods. So after we update the status of the order, we're going to call store.enqueue notification event and pass our new notification event into the database queue. We first need to pass the user email. That's going to come from the order request. Then we're also going to have an order status. That's going to come from the order object we have here. Then we also have the order ID. That's also from the order, and the number of attempts will be 0 when we first enqueue the notification event. This gives us a notification event as well as an error, but we wouldn't really need this notification event, so I will just leave that empty for now. And if there is an error, we are just going to return this error. And then I'm going to copy this and paste it in my CreateOrder method here. But before we enqueue our notification event, I want to manually assign the status of the order to be of pending type. So we wouldn't need the status when we create an order because our orders table have a default value of pending for the status. But we want to manually assign this so that we can pass the status into this order status in the enqueue notification event and also to return it as part of the order response here. But for the create order, there's one more change that we have to add inside our handler file, and that is to pass down the user email as part of the order. Right below this line here, I'm going to assign the user email from the claims. So with that, we're going to enqueue a new notification event when we create an order and also when we update the status of the order. And now onto the final part of this episode, I'm going to add these store methods to list and update the notification events that will be used by our ecom notification microservice. So at the bottom of this store mysql.go file, I'm going to add this method list notification events. That's going to look something like this. But we're going to write our own query because it's going to look a little bit different. So we'll have a query queue, and I'm going to call fmt sprintf to pass our max attempts variable inside our query. So I want to paste this query and add a couple of conditions. So we only want to list the notification events where the attempts are less than max number of attempts that we defined. And we also want to order by the created at timestamp. And we're going to define this max attempts in a separate constant. So at the top of this file, I'll add a new constant called max attempt and I'll assign 3 for the time being. Now back at the bottom here, now I'm going to pass this query into the select context method. And now we're going to ensure that the notification events we list from our ecom notification microservice are going to be in order. Then at the bottom here, I'm going to add this method to update the notification event. And I would say this is the most complicated store method we have so far. So we're going to receive a notification event as well as our notification state struct, as well as this response type variable of notification response type. This is the type that we defined earlier inside our types.go file. And this method is going to return a boolean to tell us if the state of the notification event has been marked successful or not. So we're going to have this boolean field called succeeded and return this at the end of the method. This error is going to come from our database transaction here. And if you remember from the slides earlier, we're going to perform different operations based on the response type we have. So we're going to have a switch statement on this response type. And if we have a successful case, then we're going to perform something. And for the notification failure response type, we're going to do something else. We're also going to have a default case where we're just going to return an error saying the notification response type is invalid and return nil at the end of this database transaction. So if we get a response type of success, we're going to update the notification state to sent and delete the notification event from the queue and mark the succeeded field as true. Then for the failure case, we have 2 different scenarios, but here we're first going to get the number of attempts for the event in the queue. And if attempts count is less than the max attempts that we defined, we're going to increment the attempt count of the event by 1 and update the notification event queue. In our else case, if the number of attempts for this notification event has exceeded the maximum number of attempts that we defined, we're going to update the notification state to failed and again delete this notification event from the queue. Again, I already have these methods defined to save us some time, so I'm going to paste this here. So first I have this method to get notification event attempts from the notification events queue based on the ID of this event. I have this method to update the notification event attempts in the notification events queue where I set the number of attempts and the updated add field. I also have this method to delete the notification event from the queue. And lastly, to update the notification state in the notification state table. We're going to update the state and pass down the message into the database. And if the state of our notification state is sent, we're also going to store the completed add field. That's going to store the timestamp of when the notification event has been completed. Now back inside our update notification event method, on the success case, I'm going to paste these methods that I just defined up there. So I'm going to update the notification state, mark it as sent, then delete this notification event from the queue. For the failure case, I'm going to paste that again. We're first going to get the number of attempts of this event in the database queue. And if the attempt count is less than the max attempts, we're going to increment the attempt count by 1 and update the notification event attempts. Then in the else case, we're going to update the notification state to failed and delete this notification event from the queue. And although this event is deleted from the queue, this message field is going to contain the reason for failure, and the admin will then be able to determine what to do with this notification that failed. We're now left with one more thing to do. I'm going to open my API.proto file, and right below my session response proto definition, I'm going to paste these definitions for the notification event, the list notification events request, and the response, where the response returns a list of this notification event. And I'm also going to have a update notification events request and the response, along with this notification response type that's used to define the type of this response type field we have in this request. I'm also going to add 2 new RPCs here. So at the bottom here, I'm going to paste these RPC definitions to list the notification events and update the notification event. Again, I'm going to run this protoseek command to generate the source code in Go. And once you run that, you're going to realize how these RPCs, for example, are now added inside our API grpc pb.go. So I'll close all these files and come back to my server.go file, scroll to the bottom, and again, I'm just going to paste the methods that I have prepared. So with list notification events, we're simply calling the store.list notification events and iterate over these notification events and append it to this slice of pb.notification event that we have here. If you remember, we added this to PBOrderStatus helper method to convert the store.orderStatus into PB.orderStatus. And with the update notification event method, it is pretty much the same, except that we have the switch statement to convert the response type of the pb.update notification event request into the response type that's used to pass into our store.update notification event. So for the response type success, we are going to assign the store.notification success into the response type. And of course, for the failure case, we are going to assign the store.notification failure into the response type, then pass this response type into our update notification event method. We're passing both this notification event and the notification state into our update notification event method. And with that, I want to say that this is the end of this episode. In our next part, we're going to add a new ecom notification microservice that's going to use these list notification events gRPC method in Go routines, send emails, then use this update notification event gRPC method to update the state of the notification accordingly. I hope this part wasn't too complicated and that you have learned something about maintaining the state of the events in the queue. And that is all I have for this episode. Thank you all for watching.